Hello everybody, how are you? This is the 5th lesson, and in this lesson we are going to continue the previous lesson, making loops. Today we will try to dive into more deeply, and we'll try to solve much more difficult and advanced examples. Here we have an example where we need to find sum of numbers from 1 to 100, like this: 1 plus 2 plus 3 plus till 100. Actually, there are a lot of ways, various techniques for adding the numbers from 1 to 100. One of them is Gauss Theorem. Perhaps you are familiar with this theorem from mathematics lesson. According to the theorem, sum of numbers from 1 to n is equal to n times n plus 1 over 2. So here, if we accept the n as 100, then it will be 100 times 100 plus 1 over 2, and the result will be 5050. That way you can solve it in code editor. Let's open the code editor. I should print out the numbers, the results. I will write 100 times 100 plus 1 over 2. Let's run. 5050. The result is correct. But there is also another way of doing this. You can write this code simply with loops. Let me open another example. Calculate sum of numbers from 1 to n.
Firstly, we should allow a user to enter a variable n. N is equal to
Next, run loop till the entered number by using the for loop and range function. For I in range 1 till n. Next, calculate the sum using sum is equal to sum plus I expression. What is an I? This is the current number of a sequence. What is the sum? This is a variable where you will add all of these numbers in a sequence. So in the beginning, before you start the for loop, you should initialize your sum. It should be 0. Why 0? Because 0 never affects the addition. If you add 0 to any number, the result will be that number. And in the end, you will print out the sum. Let's run. Let it be our n 100. The result is 5050. So it's correct. If you didn't understand this code well, don't worry. Now I will demonstrate it in Flowchart. Sum of numbers from 1 to 4. Let it be 4, not 100. Here on the left side I have a code that I have written in our code editor, and under we have an output. Now let's start the flowchart. For each item in a sequence from 1 to 5, I will be equal to the first member of a sequence. Then we will initialize the sum, and it will be equal to 0. Then we'll start our loop with a condition. I is equal to 5. I is equal to 1. 1. Is it equal to 5? No, it is false. So it will go to this wing and perform this operation. Sum is equal to sum plus I. I is equal to 1. Sum is equal to 0. 0 plus 1, it is equal to 1. Like this, it goes back to the condition again. But before going, I will be equal to the second member of a sequence. 2 is equal to 5. It is false. This sum is old sum. This is a new sum. So our old sum was 1. I, it is equal to 2. 2 plus 1, it is equal to 0. It will go to condition again, but before going, I will be equal to 3. 3 is equal to 5. It is false. Sum will be 3. I is 3. 3 plus 3 new sum is equal to 6. Then it will go to condition again. But before I will be equal to the fourth member, it is 4. 4 is equal to 5, it is false. Then 4 plus 6, it is 10. It will go to condition again. I will be equal to 5. 5 is equal to 5, it is correct, it is true. That's why it will go to this wing and it will perform this operation. Print sum. As sum is equal to 10, you will output a number 10. Thus, the flowchart ends. Calculate product of numbers from 1 to n. So this example is the same as the previous example, but here you should calculate the product, the times. For example, if it's 4, the result should be 24. 5, the result should be 120. I will open that example and I'll try to change only some points. Here we should find multiplication. The variable sum, I want to change to this so that it will be understandable that this is a multiplication. And this one also. And the initial value, if you make it 0, 0 times any number will be always 0. That's why I will initialize it to 1, because 1 doesn't affect to multiplication. Then from 1 to n plus 1, I will make not addition, but times. Let's run. 4, 24. 5, 120. That's correct. What if you are asked to find the multiplication of odd numbers from 1 to n? In this code, you will change only one thing, the step size. It will be 2. It works like this. If n is equal to 5, then the output will be 1 times 3 times 5. It is equal to 15. Let's see, does it work or not? If n is equal to 5, the output is equal to 15. It's correct. Now let me show how does this code work in Excel program. N, let it be equal to 5. On the first iteration, I will be equal to 1. Multiplication will be equal to multiplication times I. So multiplication in the beginning, it is equal to 1. 1 times 1, it is equal to 1. On the second iteration, I will be equal to 3 because the step size is 2. Then multiplication will be equal to 1 times 3. It is equal to 3. On the iteration 3, I will be equal to 5. Then multiplication will be equal to 3 times 5. It is 15. Then on the fourth iteration, I will be equal to 7, and 7 is exceeded. This is larger than the 5. So the for loop stops here, and multiplication result will be 15. There is a website, Zapatio.tk. This is a beautiful, simple, and straightforward website from where you can find a large number of problems. In order to solve them, you should firstly register, and after the registration, you can go to problem section, and from here you can find a lot of questions. For example, let me open the repetitions. Here are the questions. Now you can solve them and you can submit them. In this website, I have found one question, beautiful. In this question, we have to calculate number of even numbers between A and B. For example, if A is equal to 3 and B is equal to 10, even numbers between 3 and 10 are 4, 6, 8, and 10. So there are 4 numbers that we should output the number 4. 10 is inclusively, don't forget about it. Let me solve it in a program. So firstly, we need to input two variables.
I want to call the first variable as a, int input a variable. Then I want to input the b variable also.
Then I want to declare the variable c. This variable c I will use to calculate the amount, the number of even numbers between a and b. So in the beginning I want to initialize it to 0. Then I will use 4 and I want to take I variable in range. In range it should start from a. So this part is very important. You should write a and then b. B is also inclusively, that's why you will write b plus 1. Then for each member of a sequence between a and b, you should check if this member I is divisible by 2. If I is divisible by 2. So if it is divisible by 2, it means these numbers are even numbers. Then if it is even number, I want to increase c by 1. So I'll write c is equal to c plus 1. And in the end, I will return the c. This will be number of even numbers. Then let me run and see. For example, 3, let it be a. 10, let it be b. The numbers between 3 and 10 is 4. Next, let me check one more time. For example, 25 and 60, 18. That's correct. Now, I want to explain this example with Excel. For example, let it be my a is equal to 3, my b is equal to 10. Now, in the first iteration, I will be equal to a. So it will be equal to 3. Is this 3 divisible by 2? Is it even? No, it's not even. So c will not increase. C will remain as 0 as it was. Then on the second iteration, I will be equal to 4. Is 4 divisible by 2? Yes. Then c will be increased by 1. On the third iteration, I will be equal to 5. Is it divisible by 2? No. So c will remain. Then fourth iteration, I will be 6. Is it divisible? Yes. So it will be 2. 5, 7, no. 2. 6, 8, yes. 3. 7, 9, no. 3. 8, 10, yes. 4. So I will stop when it reaches the 10. Then the number of even numbers here will be 4. I think you understood today's lesson. If you have questions, you may ask your teachers. Thank you for listening. Have a nice day.